Hi Ravi. Hi, Sonam. You're getting my
Good evening,
voice?
sir. Yes, sir.
So let little bit wait to other people join. Then we can.
Hi.
So if you both have any doubts, you can ask. Okay, fine. I'm starting now. Can you able to listen to me? I'm sharing my screen.
Yep.
So we have the drawing available, and we yesterday are doing to this. If you remember it, we just created only our steel gutter with the slab and with the property itself. This will be fine. So now we need to create the first of all bearing point. That will be important. So this bearing will be at here, and what will be the distance? Can you remember it? Because this we need to provide like this. If you remember it within the drawings also, that first of all this point, this gutter depth after 100 mm, then 250 mm. So this is like 2 meter plus 45 plus 50. So 2.95. Then we need to add plus 100 plus 250. So 2.95. This will be 2.095. 2.095 plus 0.100 mm haunch plus 0.25 the slab. So 2.445. So we will be creating here y direction minus 2.445 comma minus 0.5 for our bearing. Okay, distance was wrong. It should be in Z. Again, select the same node, right? So this will be have created. We can also check it by looking at this position by 3D. Little y. Okay, this is showing it here because a little bit. Okay, this is my point. Okay, this is fine. Let me check if there is section. Right gutter I have put it here. Here I put it left. If I convert this into this, look at this thing. Okay, gap is created. No, that is fine. So this is fine. And now we need to create the, this will be our bearing point. So the bottom one will be fixed. So fix will be
-5 is which one, sir?
minus
-5 you have inputted, no, sir.
0.5, not 5. It was 0.5. Just for this pedestal height.
Okay.
Where is our boundary? We just put it fixed support because of pedestal. Now, before joining these, first of all, we need to provide the bracing point also. So, because all the things will going to be connected in this portion, we do not require bracing point. We can directly able to connect the end diaphragms because here is at end gutter we do not have any bracing. At this location, we have diaphragm available. So we can see the end diaphragm properties also. In this, it is showing. This is only connection detail. It will show. This is my end diaphragm. So here will be plate, I think, will be mentioned here also. It is 1750 12 into. We do not require this 2445. This is will be the total distance. This is fillet distance have been given, but we require the main thing is depth. Depth is 1750. And if you look at here, even this thing is not connected with our slab. This is connected only with the web. So what is mean by that? If my end diaphragm only connected with the web, this is mean this is a shear connection. This is not the moment because flanges are not connected. So moments are not going to be provided in between them. Now from where I need to provide it, I can provide it from the mid portion directly. You do not need to create any other. So here generally how we do it in the steel, let me show it. Like first I need to create for the end diaphragm, for nothing else. So I know the distance between, now I need to provide at this location. Where if I show you, I need to provide at here in between this 2 meter. So from bottom, how much it will be? 45 plus half of this. So it will be around 1.45. Or if you want to 1.045. So what I will do, I will take a reference from bottom point. Here, here, here. And we'll go again, node element, translate, unequal distance Z, this 1.05 up. It will come at this location. And we will give first of all the properties. Section and we do not require any special composite one, so it can be easily defined in I section user name.
Sir, at the center like that where it is given, sir?
Yes, I do not get your question.
At the center, the diaphragm ends like that where it is shown, sir, in that diaphragm section.
Generally, it is show not with the center, but we always assume it should be. If you look at this section.
No, here it is given, no, sir, this depth.
Where it has been given, it has given little bit, but what is going to be happen? It is giving only whole location, not total depth. Even if you look at this distance in this girder, this diagram will be little bit center. It is how much it's showing? 180, and here is 220. So we assume that you can create modeling by center, because in the end term, it doesn't matter if you are modeling shear connection little bit eccentric. Only shear will going to be provided. No bending is there, so it does not cause any moment due to the eccentricity. If I'm modeling center or if I'm modeling little bit eccentric in steel, it doesn't matter. But it should be little bit according to the drawing. Why? Because if you look at here, the height is different. We know a pedestal height will be different due to this 2.5% slope we provide in our bridge. So due to that, generally these plates in one girder come at different location, in another one come at different location. But in our modeling, we can directly provide all on equal distance. You do not require to provide.
That is okay, sir.
Yes, that is fine.
What I am asking, diaphragm from the total girder depth is 2.045 means diaphragm diaphragm is at 280 mm or 300 mm above only, but we are creating one diaphragm point at the center of the girder, means whatever the point we are creating is the bottom of the girder diaphragm point, or which one?
No, because this is 1750 plate, it will automatically take here some clearance, because my depth is 2 meter. If you minus 2 meter, it will be around 250. So 125 still will be available here.
Yes. But we are creating at the exactly at the center of the girder.
Yes, we are creating exactly at the center just for the show purpose. But in connection, you can able to move little bit up and down in the shear connection. Not if moment connection is there, then I need to create variation. Because this is a shear one, so I can able to play with it because I'm not creating as per my bearing also. What I'm assuming everything is straight right now, but little bit slope will be here due to this water can able to move
Now,
2.5%.
based on this drawing, we can create at 1.75 depth only. Diaphragm is ending like that, na sir?
Yes, this is just that is what I mean. This is they have adjusted according to the shop drawing, like for construction purpose. Otherwise, in our modeling, we always try to create from the center itself because they cannot want, they do not want this kind of plate.
No, sir. What I am asking, whatever the center point we created is the diaphragm end point or what, sir?
This point, this point, this point, and this point, starting and end point. Yes. I
Okay,
will show
okay.
you how it will look like. I will show you when we will connect it. So let me.
Okay, okay. Just we are putting center point of the diaphragm.
Yes, yes. You got this. Now I want to use I section I want to use, but I do not want to create by this. H is 1. You can see total is have been given 1750, 1.750. B1 is this. So here we need to see our B1. This will be our top flange. This is mentioned 200 by 12. And what is bottom, I think same will be here 200 by 12. So this will be B1.2. This is asking thickness of web. Web is our 12 mm. So 0.12. Top flange thickness 0.2. And B2 is bottom again 0.2. This is not required if we create like this. Why? It will automatically take all things the same similar way. And we are considering it the mid. So we will directly do not use center top command. Now other thing in this thing is also bracing. So let us also use this section. Here this bracing is here. So 2L opposite.
This TF2 and BF2, what is that, sir? Why we are not putting it, sir?
Because it will be same the top and bottom flange. But I have here, this is the top flange. I have mentioned the top flange dimension. This 212 mm, and if you look at the bottom flange, it's also 212 mm. If you do not define bottom flange, it assumes that it will be matched with the top. Even with the stat, the same thing is there. If you do the modeling, if you do not define the bottom one, it assumes that it will going to be same as the top one.
Okay.
This is fine. Angle. Double angle have been mentioned 130 into 130 into 10. This is also same, though both are same. And we have top also, which will also 130 by 130 10. And here, okay, all are 130 into 130 10. So we'll go here. Now here we can use our standard angle. If we go, first of all, Indian code, let me see if it's double angle is okay. It is showing everything. This double angle we required, not coming, so user define. Our is 130 into 130 into 10. So that's how it is look like. This is also going to be model that's the same, do not require any access. And section number 5, okay, mention it same. Close, close. Now come to my node element, create element. Here I will choose end diaphragm, this to this. Now if you look at it will look like this. And this. So actually it will look like this. Getting this? So that's how it should be.
So property of end diaphragm can you show on, sir?
End diaphragm is same. This is showing this 50 mm offset due to we need to do offsetting in our this point. The location, if I go into here, I got it. And from like this is for this one. So if you click same property, yesterday we have created now. But here I need to change little offset. This is mentioned center top. But vertical offset I can adjust, but I need to adjust the horizontal offset, which is not showing here. I need to change my offset from the left top. If I mention as a left top, then I can mention everything horizontal offset, and that should be around how much we have calculated yesterday, 1.1. Let me just confirm it. It is not showing 1.1, or it should be 0.2. Okay, minus 0.05, I think. Yes, 0.05. Okay. And if I look at this point, offset have been done, created. Okay. Yes, properties. The same will be here. But it is showing little bit. What is this? Is coming maybe 25 mm. Yes, it is just in the this offsetting, but do not have anything about the properties. Is our fine. 0. No, it is not even 25. It's very less. Something is fishy.
Which one, sir? You are checking about that distance?
Just insertion point. The insertion point doesn't matter to your. Now it is fine. So, and for this also, I'm changing this insertion point. This offset we are using center top to left top, then extreme fiber to I think 10 mm difference it is showing. Do not know why, but if I create this will be now fine. Very less, even maybe 5 mm will be there. So this is pretty much, but we have given correct properties, so no issue. This is just the insertion.
In end diaphragm, we are using center to center modeling. Center modeling.
Yes. It is look like this. We have created gap here. We have created gap here, but equal gap have been created. It doesn't matter for shear connection if you do at here connection or if you do at here, because all the force will be go by shear force only. The shear force does not create any extra moment. Only vertical shear force will remain. So do not have any issue in this kind of modeling. You do not require to put this 2.5% slope this because otherwise your modeling become very complex.
Sorry, end diaphragm, can you open properties, sir?
Sure. Same, nothing.
TF1. So this bottom all, if we take 0, it will be considering
Top
0.2, same thing only.
Automatically. Even in every software, if you use any other modeling one like STAAD or ETAP, if you do not put in the bottom one, it will automatically take the top one. And there are radius also if you require, but radius are only required for very rolled section, not built up section. This is now we need to create our bracing. So our bracing will come only at this point. Yes. Now bracing will come at this location. Let me just. So here, if we have seen the bracing, first of all, we need to see from where bracing have been joined. If you look at here, our bracing center is going like this. It is not joining at this center. So if you assume this center is at this, we can assume this point like this. So we have some eccentricity from top. If you look at here, it will give our 130 eccentricity plus the gap There is some gap also, a little bit 10 mm or so it will be around 135. This thing. From which the gap, or I think 140. This something little bit have been also. So 140 from this. So what I will do, I will again minus. What I will minus? I will calculate from this point because I have this node available. I can create this node. Yes, I can create this node very easily. So what I will do from this node, I require first of all at this point. So 1 point at this location and 1 point at this location. And this point, if you look at here, at this point, very less, like 25 mm minimum, they are showing needs to be provided. So 25 plus 135, I can consider it same for both the thing. 135, 10 mm will be gap between two angle. Why? Will be center will become, because if you look at this is my center line. So this is 10 and this is 10. And this will be 130. So that's why I'm considering 5 mm more. So 135 plus 25. It will be 160. I will provide 160 top and bottom. So from bottom, it is easy. How? Just I will provide this. And I need to first of all add 45 plus, if you see, this is the connection point. That's why they have shown nothing else here. Okay. After that, I will use the same 160 after plate. Then after from this to this point, I need to find out. This will come how much? This will come because I know this distance from the top. Now here, if you look, top is again changing here, top is again. So we will create equal one. Even we can provide not 160, 200 mm, that will be fine. If we using 200 mm, 200 bottom, 200 top, and this total height is 2000 and bottom thickness is 45. So first I will minus this 45. Then I will minus this 200. And then I will minus this top 200. So I will get this point. How much I'm getting?
This house, sir, 2045 is which one, sir?
I will let you know. Let me just confirm this. Okay, minus 400, we will have 1600. Yes. This we already know, this girder depth is 45 and this to this is 2 meter. So it will become 2045. Okay, total. And other thing what I am assuming, from this to this point, or maybe from this to this point, I am assuming 200 mm offset. 200. And this is all also I am assuming around 200.
No, this gusset plate size we no need to see, sir. Gusset plate is around.
This is a part of your connection design. Why we require right now gusset plate? This is just comes in our design calculus. Like when we do the connection design, then it will become. And these are also our only shear connection. So we do not require any bending moment. Shear connection are very easy to design. Do not require very much complex calculation. So that's why now 200, if you put this point, so from bottom, I can easily calculate this 2045.
This 130 something you have calculated, na sir? That how
that I have calculated 1600 this point.
No, that is okay. Here below you have written 135 now. That from where we have calculated.
No, this I am not considering 135. I am considering 200. So I have cut it this because here I just, you can assume a little bit here assumption can be required. That is what I yesterday also told you. This is a pretty much very detailed drawing, but we need to provide little eccentricity from the top and bottom. So it cannot, moment cannot be generated in our bracing. That's why. Otherwise, if you directly provide bracing from your this point, modeling point like this and this. So it bracing will have moments. So that we do not want. Let me create it, then you will able to understand. And also we will create this bracing. If you look, this plan bracing is also required. This one. I think this one is how much is mentioned. Now if you look, all bottom bracing is 100 into 100 into 10. And what is top? I think half top and half. This is bottom 9, bottom 9. Half bottom splice, bottom splice. This is also center of splice, bottom blade. Okay, this is half bottom, half top line clearly mentioned, but okay, they have only in bottom, not in top. Not in top, only in bottom. Okay, got it. So first of all, I will just create this thing. What I want to do, let me open the whole model. So this I have already created. So these point needs to be model.
What is there? Bracing is at only bottom, sir, or top? Fully connected,
no,
sir.
I will show you. I will show you a little bit unless you will see this 3D model. It will be little bit confusing for you. So let me first create here what I have calculated it. It is around what is this distance? Query node 2.445. So copy this and go to your node element, translate Z minus this point and apply. So now this point have been created. What I need to do, I need to first of all move this point how much? To 245 distance. 0.245. So this will be my bottom bracing point. Move. And after that, I need to create one copy node. Again, Z copy. It will be 1.6 meter. Now I will try to create one bracing so you can able to understand this thing. Now how bracing have been shown. Bracing will be look like. Where is my create element? And here this and also this and also this. And what is another thing I need to do? This. And now if you look at the 3D view, it will look like this. Okay, it is showing if I want to change the angle, I will if this is fine, it will take only axial forces and shear forces right now. So I can able to change the angle also, like this is right now top is mentioned, but I can change it like this also if required. This kind of. So
Which kind of thing, sir?
this one you can see angle have been shown this from the top side, but in Midas it is showing another side. That we will do later what, but before that I need to create all the bracing. Now if you look at the girder with the bracing, that's how it will look like. And if I show one section about it, like and now you can see that's how it is going to be connected. So that
This
is
distance, how you model, sir, from bottom?
which thing?
This first you have created the nodes for which one, sir? Directly
I have created
created.
at this node. Then I've shifted this node to 245 mm. Then I've created another node at 1600 mm. So here the clear gap
No,
is 200
already
mm.
at this bottom point node is there, no, sir?
So I have shifted that node. First I have created,
No,
then I have shifted.
earlier for girder the bottom there is a node, no, sir?
No. There will be no node. There only top node will be there, na? How can be another node? I need to
No.
create that node.
No, girder bottom, sir.
Girder bottom, you need to do the this thing, na? Translate this node to the bottom. How you will get
Okay.
two nodes for single entity? We will have only one
Okay.
node.
Only
Yes.
one top node will be there.
Yes. First, then you need to do. Now another part will be these bracing. This you everyone understand that this how we created it. So what I need to copy this to all this node also. So let me do the copy also. So just select like this, or maybe if I change this angle, let me modify the elements. Here, if you look, this table will come directly, and it is mentioned beta angle. So I will check one by one if by 90 degrees, it is how much it is giving me. So when you do that, you will have pretty much understanding. If I want to see this one, I have changed 90 degrees, but not anything have been changes. Where is my element table has gone? I will again select it. Here is beta angle, 90 degree. So you can see this have been changed. So now just complete this and come into. Now it is more look like as per the drawing. If you look,
Means we are
that's how.
rotating this one, sir?
Just axis. I have rotated the axis. So if you look, it will be look like this. From back, it will look like this. But from front, it will look like this. Now more look like the actual one.
No,
So,
this double angle, how it look like? We are rotating that one, sir?
Yes. You can see that's how double angle will look like. Can you see from back? This is one angle and bottom is another angle. Back to back.
Earlier, how it was, sir? Earlier, it is like.
Earlier, it was from the top.
What, sir?
From top, it is look like both the angle from top.
Okay.
So
We
now
have
this.
rotated that one like this.
Yes, I have rotated it. Now we will just copy paste these things at this locations. And how we will do? We will go into our first of all translate. Here copy unequal distance as direction, and best what we will do? We will just measure the distances. First distance is 6.5, comma, another distance 4 point this, comma, another distance 6.059, comma, then another one 4.9275. I think these both will be same if I remember it. 4.64. So yes, after that it is. Now click apply. So now you can see everywhere it have been provided. So this is only this. You should also call it kind of mid diagram kind of thing. This is just perpendicular bracing. But here another bracing have been shown. This is one bottom bracing have been shown. And this we also need to be provided. In top, we do not have any bracing. That is fine. That is good. So only bottom we require. So we will create that. But this distance needs to be anything have been mentioned this point. Nothing have been mentioned. We can directly able to divide or assume this.
This is how, in which view, sir?
This is bottom view. Let me.
Okay.
I will create it, no issue. But I'm just what I'm seeing. What is mentioning 1, 2, 3, 1, 2, 3, 4. Then again 1, 2, 3. 1, 2, 3, 4 will come. According to the distances, they are dividing. They have not mentioned any point here. But then I need to divide accordingly. But here minimum have been given 350. So if I consider this in 350 and what is my distance? 4927. 4927 minus 350. So 475. In this, we have one full bracing and one half. So it will be around 1.5. So 1.5 divided. Okay, 30501, and another one will be the half of 3050. Maybe 3 meter. You can provide it divided by 2. Yes. Okay. So this point we will provide at 150, and this will be 3 meter. And but right, if you look at here, at this again things will change. Why things will change? Here it is around, if you remember it, 6 something. Yes, I think it will be fine. It will be workable. 6 will become 1.5. Okay.
Which distance, sir? 3 meter.
3 meter this in both the distance, and this we will adjust accordingly. So this will be maybe we will provide from this to this 1.5, this to this 1.5, and this remain will be the remaining one, because it is giving this thing around 6.015 something. So that mm distance can be ignored.
Anywhere it is mentioned, or we are assuming this one, sir?
No, it should be equal distance. So what I have done, I have calculated, it is giving me around 1.525. So I'm considering 1.5, the remaining one will be automatically will be considered. Because no issues with the bearing. You can even, I'm just following drawing, you can even adjust according to your, you can provide very equal bracing. I'm using this one, that's why do not want to conflict this drawing. Otherwise,
each spacing is 1.5, sir?
Not each. This in 3 meter, and from this to this is 1.5. So this to this
3 meter, how you calculated, sir?
Yeah.
This 3 meter, first 3 meter.
How I calculated it? I've calculated by this thing. If you this minus this thing by, first of all, minus the 350, so you will get some, how much value you will get?
474627.
Just minus it, 4927 minus 350. Okay. So you will get 4577. So what I'm doing 4500 I'm considering, and if you consider 4500, so one is 3 meter, another one is 1500.
Okay. For
Divide
that, any nowhere nothing is given. That is.
Yes. So we are considering even no issues with it. You can consider it. This is just because I'm following this drawing for you. That's why I'm mentioning. But otherwise, if I do it, I will try to follow equal spacing and everything should be equal. But this is already this is drawing have been used. This is a project. A lot of, I think, unlimited number of bridges have been constructed due to this drawing. So that's why I'm using it. Even you can follow anywhere if you required for this this steel drawing for your project. So this is, it can work for, just need to be just like this is valid for 36 meter. So you can adjust it for 34, from 32 to 40 meter a little bit by changing the web or flange thicknesses. So, and if you have increased the span, you can also do the increase the depth of girder. And if you decrease the span also, we can reduce little bit depth of girder. But this same steel can able to work in ranges like 4 meter plus minus. Okay, now we will go. Where is right here? So what I need to do? Just bottom we need to create, because not the top one. If you are looking, only bottom is there. So first of all, this point, what I will do? Where is my translate? This should be in minus 1.5 comma minus 3. That will be up to this location. Then afterwards, positive, same node. So this should be for this. And I think this distance is how much was there? If you even see, so here is this 1.5, then again 3. .5, this one. And this should be 3. So this will be maybe if 3 equally, yes, it is coming. Then again 3. Yes, I think together everywhere we can easily able to do half of it. We can also use query. Now if you look from this to this point, it is giving around 5. And how much it is giving around? This is 6, that is fine. This we can divide a little bit less because it is giving around 5. So 2.5. And this one is giving 4.6. So this we can consider is 2 point little bit less, 2.4, not 2.3. Yes, 2.3, 2.5, 2.3. Let me just create this 2.5. Then 2.3. And what is the last one? 2.3. Now we will provide our bottom bracing. We will select this one. Now how it has been shown. Okay. It is coming from one girder to this girder. Okay, this to this. So what we need to do? We need to go and first of all, this bottom bracing we need to create it because this is a 10 into 10, 100 into 100 into 10. This is the one. Go to one element, create element, change bracing this one. It is mentioned coming from this to this. If you look at here, this to this. And this both are connected at some midpoint, like this two. This point will come here. That is me. But this so that's how we need to provide this. One more thing is also here. This is not correct. This we need to little bit move, not looking good. One. Now what will be the remaining one? It should be at this location. This have been remaining. This have been remaining. This have been remaining. Now that just a little bit move this one. Maybe 0.5. Now that's fine. But what is required at this location? At this. So what I will do, We'll just do this one. This one. Okay. This, that. Is another.
सर
Yes, Meher. We can create this.
सर
Mm-hmm.
इतना वेब में शेयर आता है उसके 2.5% के लिए सर डिजाइन कर देते हैं ना आप
किसने वेब में जो शेयर आता है उसका
2.5%।
हाँ उसके लिए करते हैं, वो मैनुअली होता है, लेकिन तुम्हारा लेटरल ट्रोजन बकलिंग और दूसरे चेक भी तो आते हैं, उसका क्या करोगे? पर हमें
वो तो सर
मतलब एक तरीके से
गर्डर का
ये मॉडल
कैपेसिटी
करना
चेक करते हैं
पड़ता
ना
है।
सर।
हैं?
वो तो एमसीआर क्रिटिकली चेक करते हैं ना सर।
नहीं नहीं नहीं, ये भी ब्रेसिंग मॉडल करोगे तो उससे फर्क पड़ता है पूरे मॉडल में, फोर्सेस में डिफरेंस आता है हल्का।
सर
जरूरी
वो
होता है क्योंकि वो तो सही कह रहे हो, 2.5% के लिए करते हैं चेक, लेकिन अब वो पहले होता था जब हमारे पास ये कोई मेथड अवेलेबल नहीं होता था बियरिंग अपने इसको ब्रेसिंग को मॉडल करने के लिए। लेकिन अब जो है तुम्हारे पास मेथड अवेलेबल है, तो अब कंसल्टेंट मानते नहीं है, बोलते हैं कि डायरेक्ट पूरा का पूरा मॉडल करो और उसमें से ही मुझे फोर्सेस दिखाओ। वो पहले हम करते थे 2.5 के लिए, जो वेब में शेयर आती है उसी के लिए डिजाइन करते थे, लेकिन अब नहीं होता है वो।
क्योंकि सर यहाँ देखने जाएंगे तो फिर वो
हैं?
एग्जैक्टली कनेक्टेड तो है नहीं सर।
नहीं नहीं, अभी टेंशन लो, सब होगा, अभी रिजिडली कनेक्टेड हम करेंगे, लेकिन उसके बाद उसमें से उसको हम डिफाइन भी करेंगे कि ये ब्रेसिंग है।
अच्छा ऐसा
इसमें
है।
बहुत कुछ चीजें होती हैं जो डिफाइन करनी होती हैं। जो हमारी एक्स डायरेक्शन है उसमें सिर्फ हमारा ये जाएगा, सिर्फ एक्सियल फोर्स जाएगी, और जो वाई डायरेक्शन में रहेगी अपनी, फिर ये जो है मेन, इसमें हमारा थोड़ा बहुत ये मूवमेंट भी रजिस्ट कर लेता है, और एक्सियल फोर्स तो जाती जाती है, शेयर फोर्स तीनों फोर्सेज चली जाती है, लेकिन इनमें नहीं जाएंगी हमारी क्रॉस में बिल्कुल भी। तो वो हमें डिफाइन करना होगा, वो हम करेंगे अभी, जब अभी आगे जैसे प्रोग्रेस करेंगे मैं दिखाऊंगा वो भी। पहले लेट मी फिनिश दिस, इफ आई हैव वाई -5 not be, that's why I do not do this drawing, because this is not on this, you can say not equal drawing, everything is pretty much at different locations. So, and one more thing I need to see. Here I do not require this node little bit, because 350 offset will be required. Now it will look like this. You will have cross bracing, you will have bottom bracing, then we have this also beams top and bottom. That's how this whole bridge going to be look like. Now anyone can ask, and if they are not able to understand up to this position.
So this bottom bracing, can you tell once, sir?
Little bit, I am not able to make it the equal distance. Otherwise, I need to calculate. It will take a lot of time. Every distance I need to divide it. So that's why it is showing little bit different. This like this point, it will go more of in this location.
Actually, 3, 1.5, whatever we have discussed, that is not
This
the
is coming
distance. Okay?
fine. Up to this location, this is fine. But after this, pretty much distances have been updated. So that's why it is not looking equally spaced. But when they're going to be construct, let me create this equally. Okay, if you look at here, this bracing should be wrong. And which one it is? I know about it. It is this one. This, and this. I will delete this. I will create one more node. Or maybe just create this. I will use translate. Copy X direction. This should be 2 meter. Apply. Go to, and I will change this thing also. Little bit more move. Maybe more. Now that is looking fine little bit. Or if you require more, not, no, it will be little high. That is fine. And this we will create it. Create element, again same. So this will be look like this. It does not matter if our bracing is matching anything. This is just to resist your when there will be sway, like bridge will try to move in transfer direction. So this bracing just provide the resistance, nothing else there. Or it will take your whole bridge as a one single part. Your bridge will be here. So that is
Why
the
it is
only
not
part.
provided in the top is because slab is there, sir.
Yes, what are you saying?
In top, why it is not provided, sir? Because of the slab
Generally
is
top,
there.
you do, why top is not required? Because in top we already have slab available.
Yes, that's right.
But bottom we do not have anything. What will happen in steel bridges? Sometimes top flange will remain in your position, but bottom flange try to move, try to do the buckling itself. So that's why. As per code, it is not mentioned here. We only need to be provide torsional restraint at the top, but we are in general life it can be happen. But that's why it is common practice to provide bottom bracing. Generally, it is very common for all the bridges to provide bottom. Top, you can ignore it, do not require, because slab is already there. So slab will be very rigid, and due to that, our bridge will not go anywhere. Let me delete this extra nodes.
Sir,
Yes.
what is the difference between this moment connection and shear connection, sir, in steels?
Moment connections will, what will happen in bearing? If you remember, bearing will transfer only axial forces or shear forces, but do not transfer any moment to your substructure foundation. You know this concept, na?
Yes, sir.
So same concept happen with the steel. If we provide moment connection, then moment from one beam to another beam going to be provided. And if we provide shear connection, only shear force will going to transfer. Let me show you this thing. What generally happen? If you have, let me draw any kind of girder or beam, that's how, like this is top flange, then web, then your bottom flange. Now there will be another top flange, then you have bottom flange. Not able to make very accurately. This will be your another web. Then there will be another plate. Now we want to join these two plates. Very simple, I'm telling. So what will happen? We need to provide what generally you have seen it or everyone knows. We need to join the webs. So web will be joined like this. And there will be bolt here. And if I'm removing the web, then you need to join this top flange like this, bottom flange like this. There will be bold mention like this, like this, like this, like this. So this we have joined. What I have done, I have joined top flanges, bottom flanges. Now we required web also. Web will be connected like this. Then you will have bold set here, here, here. Not able to do accurate one. Just so you have joined web also. You have joined bold. What will happen normally if you read a normal theory of I-beam or any kind of beam, like if it's a T-beam or it is a U-beam or different, it is a channel, or if you have different. Now I'm talking about only I-beam. So I-beam is what will
Theory
happen.
of what, sir?
Huh?
Normal theory of something.
Normal U or anything, nothing. Just only on normal steel section. In I-beam, as per the theory of steel, says that moment will be resisted by your flanges, top flange and bottom flange. Both will take moments. Means if bending will going to be occur in any kind of beam, then our flanges will going to resist our moments. This is the normal theory of steel in major axis, not in minor axis, then web will take. So in major axis means along this one. Minor axis will be along this. So this is known as major. First of all, you also know about the major and minor axes. Steel will have different properties and everything will change according to the axis also. So this is major axis. This is minor axis. So if you have moment about minor axis and if you want to resist that moment, so our flanges are the main part which will going to resist your moments. Then if you want to resist the shear force, so shear force will not be resisted by your flanges. Shear force will only be resisted by your web. So what will happen if you provide connection only through the web? So if I do not provide top flange and bottom flange connection and I will provide only web connection, so it means only shear force it is going to be provided from this web to this web, or from this web to this web, or this girder to this girder. Because I have not provided any connection between flanges, so no moment will be transferred between these two beams. Only shear force will going to transfer. Shear force like one girder is going up and another girder is going down. That is braking force. But if I want to provide the moment, then I will use flanges also. So same thing is here. If you see the connection, everything is provided with the webs. My whole bracing have been shown to be provided with the web. No part of your top flange or bottom flange is connected with your bracing. You are seeing this? Even your plate, gusset plate is ending at this location and at this location. So your gusset plate is not going to be connected with your top flange or bottom flange. So no moment will going to transfer from your main girder to your bracing. And same will be there if bracing will have internal, because of self-weight, they have some moment. So that moment will also not going to be transferred to your girder. Only shear force will be there. Shear force, and another thing is your axial force. Axial force will come, compression and axial force will be taken. But this bracing will generally take your axial force, but this transverse beams will take your axial force plus shear force. Both will take. But this one, we assume that this will take your axial force. Shear force will already will be taken by your transverse beam. So no shear force will also go in this one. Only axial force will be there. What will be the axial force? Axial force will be, first of all, if one girder is going downward, like my live load is on this part, okay, and this will be remain at same location, then this girder will try to go in bending. So this bracing will try to resist this bending also, and main girder also have their own property. So due to that, there will be two forces which will resist your bending. First of all, your main beam resistance, because we have to check our web for shear and the bending. So bending will be taken by directly the flanges, but shear will be there. So that shear will be resisted by our this thing bracing. So that is one case. Another case is that if some wind load or earthquake load come from your longitudinal direction or maybe transfer direction, so whole bridge will behave as a one part, not a different part, because not slab will not going to make our girder as a one, bracing will make. And if locally our my girder will want to sway, sway means it will go in any direction, like where my pencil, if this will try to do like this, or maybe sway, this is the torsional, but sway will be different, like this. This is laterally later torsion buckling. If this is happening, so this my end bracing or this beams will resist this lateral torsion buckling. So everything is going to affect my whole beam and bridge. That's why we need to provide this bracing point. And another thing, in the design, my effective length is also going to be reduced. Like in design, we need to provide the effective length of girder. So that I will consider according to these bracings. So that is also one good point. If you want to reduce your effective length of girder, so we always try to provide the bracing. Otherwise, you cannot able to reduce the effective length for design purposes. So these all points need to be considered in steel design. That's why we are considering directly in modeling also, and we can design directly bracing through the model also. That is the thing. So now we have provided like this. So, but the remaining part will be here. Wait a moment. Now we need to connect these bracing node, and every node should be from top node, because we know we have model only from the top node. So what we need to do, we need to make this as our rigid link. We will need to provide it. Our top node will be our master node, and our bottom node will be our slave node. So let me just do that. So if you see any bridge, maybe steel bridge, it will from the bottom it look like this. Generally, if anyone has remembered it going downward from any steel bridges.
Sir,
Yes.
sir, why we are providing only shear connection here, sir? We can provide moment connection also, no, sir?
That is good point, because you have not designed, I think, steel previously. If you provide moment connection here, what will happen? Just tell me. As per your observation, एक structural engineer
ऊंचा हो जाएगा सर, वो तो बहुत ही हेवी सेक्शन चाहिए होगा.
नहीं, मैं विघ्नेश से पूछना चाह रहा हूँ. Maybe he can answer it. His own question. What will happen if I provide moment connection? Just think what will happen if this is all bracing will have the moment. I will tell you what will happen. Whatever the moment coming in the beam, like 2000 moment is coming, okay, at this location L by 2. That 2000 will going to be directly go into our bracing.
Okay.
So bracing will fail.
Okay.
So that is why we never provide a moment connection for the bracing. So Generally, if you work any steel, connections are very important because according to our connection, our sizing changes, our this thing purpose of our steel behavior changes, purpose of building or structure changes, everything changes. That's why steel is totally different kind of field, and concrete is totally different. In concrete, all things are momently connected. Nothing is like we provide. We have some secondary or primary beams, but everything is connected through concrete. Nothing is like freely or sheer connectivity is there. So this is why, that's why steel is very good. So we can differentiate in our joints, or we can play with the joints according to our requirements.
So torsion, which is the important things in steel, sir?
Torsion is just bracing. Bracing is the main. Lateral torsional buckling will be resisted by your bracing points. Because what I will do, I will divide my
No, bottom bracing or this
this one, the
mid
all
diaphragm?
this one.
This one.
Yes.
Bottom in bottom flange, whatever we have connected, that is also.
That will not play this much effective, but this will play.
This is nothing but like a mid diaphragm.
Yes, bottom is
Equal
also there. There is, I do not remember the actual use. If I remember it, the bottom bracing. This is just for the bottom flange should not sway or should not go.
सर वो अपन ये विंड का
हाँ।
जो ट्रांसवर्स डायरेक्शन में आता है ना,
क्या क्या
सो
क्या?
विंड सर,
हाँ, विंड ही तो कह रहा हूँ, sway हो जाएगा ना वो।
हाँ
इसलिए
वो स्वे
bottom
कर
पे रहता है।
देगा। और
हाँ,
अगर
नीचे
जो
का।
अगर ये दो कनेक्शन के बीच में अगर ज्यादा लेंथ है ना, तो
हाँ
अपना लैम्बडा का KL वैल्यू आता है ना, वो ज्यादा
हाँ
बढ़
हाँ हाँ,
जाता है,
वो चेंज
तो
हो
फिर
जाती है
वो
थोड़ी।
MCR वैल्यू आपकी कम हो जाएगी, तो फिर वो ज्यादा ही जल्दी
मतलब है इसका भी
बकल कर
यूज,
जाएगा।
लेकिन बेसिकली ये तो मेन थिंग है ही।
नहीं सर, नीचे वाला भी वो इफेक्टिव ही
नीचे
रहता
वाला
है।
क्या होता है, बॉटम फ्लेंज के लिए होता है वो बेसिकली।
हाँ, पर जनरली सर कंप्रेशन फ्लैंज बकलिंग में फेल होता है ना।
हाँ,
हम्म,
सो लेकिन हम जब
सर
इफेक्टिव लेंथ कंसीडर करेंगे तो यही लेंगे, ये वाला।
टोटल फ्रॉम
दिस
डायफ्राम
टू
टू
दिस।
डायफ्राम।
नो,
अच्छा,
हाँ, ये नहीं लेंगे
ओके।
लोकल। व्हाई वी विल नॉट टेक, बिकॉज इट इज ओनली कनेक्टिंग एट बॉटम फ्लेंजेस,
मीन सर
नॉट।
लाइक मैंने चेक किया था ना, तो जब इरेक्शन करते हैं ना, तब तब अलग मीन्स लेते हैं, ये क्या बोलते हैं, मीन्स ये तब ये ब्रेसिंग टू ब्रेसिंग लेते हैं, बॉटम ब्रेसिंग टू ब्रेसिंग। फिर
हाँ
जब
हाँ
हो जाता है कंस्ट्रक्शन, फिर बाद में यहाँ से यहाँ लेते हैं।
हाँ, नहीं नहीं
इतना
नहीं
क्या
नहीं नहीं, अलग पॉइंट रहते हैं इसमें। एक पॉइंट तो
मीन्स
यही रहेगा
फॉर
कि
डेड लोड एंड
विदाउट एनी,
कंस्ट्रक्शन सीक्वेंस
हाँ
दोनों
हाँ,
का अलग वो
कंस्ट्रक्शन
चेक
सीक्वेंस में हमें डिफाइन
करते
करना
हैं ना।
होता है कि ब्रेसिंग पहले कनेक्ट हो रही है या बाद में हो रही है।
हाँ
कभी
वही
कभार
वही।
क्या होता है, अब हमारे दो गडर एक साथ ब्रेस होके आते हैं और दो गडर एक साथ ब्रेस होकर आते
हाँ
हैं,
मीन्स
और ये
वो
बीच वाली ब्रेसिंग जो है साइड पे डाल लगा देते
प्लाइस के ऊपर डिपेंड कर वो।
हैं। हाँ, वो तो स्प्लाइस के ऊपर नहीं, कभी कभार पूरी असेंब पूरे के पूरे गडर, दो गडर एक साथ बन के भी आते हैं, साइड
हाँ
पे
सर,
असेंबल।
मैंने तो कभी कभी ऐसा भी देखा है कि ड्राइंग में मेंशन रहता है कि सपोज ये आफ्टर कंस्ट्रक्शन आपका टॉप स्लैब है, वही रजिस्ट कर लेगा, तो फिर आपको
हाँ हाँ, वो भी
बॉटम ब्रेसिंग्स
उसमें
की
क्या होता
जरूरत
है,
नहीं है,
उसमें मैं
वो
बताता
निकाल
हूँ उसमें
सकते
क्या
हैं।
होता है। वो
हाँ
भी हो सकता है, उसमें ना वेब की थिकनेस बहुत ज्यादा होती है। अगर
हाँ
तुम्हें
हाँ वो
टॉप स्लैब से रजिस्ट कराना है तो
यस यस।
वेब थिकर होने चाहिए, और दूसरी चीज क्या होनी चाहिए, स्टिफनर्स होने
अंडरस्टूड
चाहिए
अंडरस्टूड
प्रोवाइड।
अंडरस्टूड अंडरस्टूड। वो फिर
हाँ
C/D फिर टेंशन फील्ड वो चेक
हाँ,
करना
वो
रहता
टेंशन
है।
फील्ड वाला मेथड है।
अंडरस्टूड।
वो जरूरी नहीं कि वो तुम फॉलो करो
नहीं,
हमेशा, क्योंकि
हाँ
हमारे
वो
पास दूसरे
लेस देन
मेथड भी
वन
है ना।
होगा तो फिर फॉलो करना
सिंपल पोस्ट
पड़ेगा।
क्रिटिकल मेथड भी तो है।
हाँ जनरली तो सिंपल पोस्ट से ही कर लेते हैं।
तो दोनों मेथड अवेलेबल हैं, लेकिन हम क्या यूज करना चाहते हैं डिपेंड करता है साइट पे।
हाँ
हाँ,
नहीं सर,
ये
अब अगर आपकी हमारी लॉन्जिट्यूडनल जो मोमेंट है M बाई,
हाँ, लॉन्गिट्यूडिनल मूवमेंट
वो
ठीक है।
अगर ये दो दो फ्लैंज सफिशिएंट नहीं है, तो एक हम क्या करते हैं कि
एक्स्ट्रा तुम
बॉटम
एक्स्ट्रा
से
फ्लेंज भी दे सकते हो,
हाँ,
एक्स्ट्रा फ्लेंज लगा सकते हो, कोई
या
नहीं।
तो सिर्फ बॉटम में एक्स्ट्रा फ्लैंज देते हैं, या
हाँ,
तो फिर लॉन्जिट्यूडनल स्टिफनर देते हैं सर।
स्टिफनर दिया जाता है वेब के लिए, मोमेंट के लिए जाता है। लॉन्ग फ्लेंजेस दिया, एक और प्लेट लगा देते हैं नीचे, वो
सर
स्टील के
मैंने
साथ।
कभी मैंने ऐसा भी देखा है कि एक
क्या?
बीच में थ्रू आउट लेंथ एक स्टिफनर देते हैं, लॉन्जिट्यूडनल स्टिफनर सर।
हाँ, वो भी होता है, वो बताओ क्यों होता है? वो वेब में जब तुम्हारे ये हम वर्टिकल स्टिफनर लगाते हैं ना, जब वो सफिशिएंट नहीं होते तो फिर हमें लॉन्गिट्यूडनल स्टिफनर देने पड़ते हैं।
यहाँ तो फिर बॉटम में प्लेट लगाओ, यहाँ तो फिर बीच में स्टिफनर लॉन्जिट्यूडनल
नहीं
लगाओ
नहीं
ऐसा।
नहीं 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 नहीं, डिफरेंट कॉन्सेप्ट, तुम
हाँ
डिफरेंट
वही
कंफ्यूज हो
पूछ
रहे
रहा
हो,
हूँ, इसलिए तो पूछा सर।
कंफ्यूज हो रहे हो तुम। इसमें क्या
वो
होता
क्या
है,
करना है उसको?
देखो, एक तो ये स्टिफनर लगते हैं, ये हो गए, ठीक है।
हम्म,
अब जब हम ये स्टिफनर लगा देते हैं, व्हेन वी पुट दिस स्टिफनर, दीज आर long this vertical
लेटरल
stiffener,
टॉर्सनल बकलिंग के लिए।
lateral stiffener. No,
हाँ
no,
यस।
not the lateral torsion. You can say there is a lot of things, not only buckling. There is
हाँ
a your
बियरिंग
shear,
स्टिफनर्स भी रहते हैं।
shear also. There is a shear also. अगर तुम्हारा, if we have our web maybe 12 mm or 16 mm, so generally stiffeners always come. What will happen? Then you provide stiffeners also very low, like 8 mm or 6 mm.
और उसका 2/3 प्रोवाइड करते हैं
हाँ
टेबल।
हाँ, two, what I'm telling ना, like 16, so we can provide 8, like 12, we can
हाँ
provide 6. Now this stiffener is also not adequate, then we provide this one, this longitudinal stiffener. What is happening here? Let me tell you. I need to create. If I
ओके
create,
ओके ओके अंडरस्टूड सर। हाँ समझ गया।
your panel is
हाँ
dividing.
पैनल वो सर
Panel is
टी
dividing.
बाई डी
Our
डब्ल्यू।
main purpose
ओके
is
ओके
that
हाँ
we
हाँ।
need to divide our panel. So
तो
this
फिर वो
panel will
भी
become,
हाँ वो भी
yeah.
दूसरी बार बकल होने लगेगा। सही सही
हाँ,
सर। ओके ओके
वरना
अंडरस्टूड।
क्या होता है, लोकल बकलिंग होने लगती है जब स्टेपनर प्रोवाइड करते
नहीं
हैं।
हाँ मैं
एक होती है
समझ गया
ग्लोबल
सर।
बकलिंग। ग्लोबल बकलिंग कैसे होती है वो भी
हाँ
समझो।
वो
मतलब कोई क्वेश्चन, इफ एनीवन वाज आस्क्ड, दिस इज इंपॉर्टेंट फॉर एवरीवन, इफ माय गर्डर इज हियर एंड समवन सेड ग्लोबल बकलिंग, व्हाट विल हैपन? ऑल दिस गर्डर विल बी
ओवरऑल
look like
बकल।
this, but not buckle, it will going to be like globally from one position to another position it will go. It is known as global torsional buckling, or global buckling normally call it torsional buckling. Yeah, no, people normally is also call it global buckling. Sometimes we call it torsion, but it is not just the torsion. Whole girder will try to topple in this direction. But in this, what will happen? If one local buckling also happen, what will happen? This all things will remain same, but at this location,
क्रिपलिंग
or maybe at this web location, this try to topple this, like it will become like this.
बल्ज।
Yes. So from avoiding this, we require this stiffener. Then still it is generating. Then we provide the longitudinal stiffener.
Sir, for
Oh,
this
table
global
two.
buckling, which stiffener, and for this one, which stiffener? It is?
Global buckling, you do not require any stiffener. You require a strong webs, stiffener chair, and also your top slab. This we will top slab. Our top slab will try to resist our global buckling, and also our bracing. And stiffeners also will try to block it, because what we'll do, we try to what will happen in lateral torsional buckling, we need to consider the effective length. Okay, from one point to the other point. If you do not providing anything, so our effective length become bearing center to bearing center. That will be 36 meter. But if you are providing any bracing or any stiffener, so our effective length change will be into that distance between two stiffeners, or from end to one stiffener, whatever the highest one. Like
No,
if I'm
bracing and
providing
stiffener, what is the difference, sir? Now, whatever we have provided is the bracing, na?
yes, bracing and stiffener difference is that stiffener also provide strength to your webs and also provide resistance to our buckling. But our bracing will not provide any strength to our web. It only provide resistance to your buckling. That is the difference.
Now,
But
whatever we have provided is the bracing. Stiffener means
yes,
it will be connecting
stiffener with
the
the web.
entire good
Yeah. Yes,
spacing
stiffeners
between
are
the
here.
girder.
I will tell you where is the stiffeners. Stiffeners at the connection location. Still here it is shown. If you look at this position, this thing, this is a stiffener, because they have connected everything with the stiffener plate. And if you look at the connection, you can see this thing, maybe more clear. So here a stiffener are also there. This is totally a stiffener, because your connection can only possible through stiffener. And we have also, So what here will be happen? Our stiffener will resist our web that
Two
provides strength
stiffener
to
or
the
only one stiffener, sir? This is
one stiffener. Two stiffeners
Hmm.
are required generally at bearing location, but in this even bearing location not required, only providing one. But I think this thickness will be more. If you look at 20 mm, and this will be okay, same they are using. Generally, this will increase it to 25 or, but I think in the design does not require it, so they do not increase this thing. It depends on the at the checking time. We need to see there will be some more shear force as compared to this one. So that's why they have using the same stiffener. I do not know why, but this stiffener can easily able to reduce it to 16 mm. So here, if you see, stiffeners are also provided and bracing, because bracing connection generally to be provided with these stiffeners. Like this is a stiffener, then gusset plate will join with the stiffener, then our bracing will be joined with the gusset plate. So that's how
are
the
that
normal.
bolt or something will be there, na sir?
These are the no stiffeners will be welded. Do not
No,
require any
gusset
bolt.
plate and bracing will be welded.
No gusset here as per this connection they have shown gusset plate and the stiffeners are bolted, but your bracing and gusset plate are welded. This you see welding are there. So they are using what they are using. I will tell you. They directly take this bracing as from the factory itself and directly put at this location and just do the bolting. So it saves a lot of time. So everything will be welded, and this will be from this is welded through this middle gusset plate.
Gusset plate and stiffeners are bolted, na sir?
Gusset plate and stiffeners are bolted here. Okay.
That
But
for
generally,
that local
even
buckling, whatever we have discussed, for that what we will be providing, sir?
for local buckling, we have this stiffener.
Longitudinal stiffener, sir?
I guess sir.
Web and longitudinal, not the longitudinal, this transverse stiffener. Longitudinal will be perpendicular to it, like look like this. This is transverse system. Longitudinal will come like this. This very rarely you will see. If we have very generally what will happen, you do not work like this. Sometime what will happen, contractor will ask you to design the steel bridges according to the thickness available. Sometime it only have 12 and 16 and 20 thickness available, and he said only use these plates. Do not go beyond this, do not go below it. So what will happen in this kind of situation? We need to provide 12 mm our web, then we need to provide stiffeners the same or maybe lesser plate. Generally lesser plates are available. Then even our stiffeners will try to buckle it. Then we need to provide this longitudinal stiffeners also. So very less project you will see longitudinal stiffeners, not many project, but we can provide it. This
how it
system,
will be, sir? How buckling will be happening, sir? Means
and what will happen? This will buckle like this. You're seeing my mouth like this. So this stiffener first of all try to resist this buckling, but what will happen? This will resist at the middle. Maybe it will create more buckling in our this stiffener also, and with the web also. Little bit stiffener will try to, what will happening? Now little happening, little, very little. But due to this happening, our stiffener will try to also buckle it. Like at anywhere I have shown the stiffener. Yes, here is the stiffener. So what will happen here? Generally, this stiffener will also buckle like this, and this plate will buckle like this. So what we do, we provide longitudinal stiffeners. Their formulas have been given to predict, but this is the behavior generally.
This one is what, sir? Plate.
Plate is buckling like yes, buckling like this. It is not like this. It will be buckle straight. Yes. Not that always your plate will going to buckle straight. It is buckle in diagonal direction generally. So for resisting it, we need to provide again this one. First, we provide the vertical this transverse stiffener. What will happen? We do not provide transverse stiffener in very less spacing like 2 meter. Generally, we keep it around 3 meter or 4 meter. So it creates a gap between. So in that panel, maybe more buckling is happening. So we provide longitudinal stiffness because we cannot go beyond our web plate also. Like if my web plate is 12 mm, so I cannot provide stiffeners to be more than 10 mm. Generally, maybe so that for that position, I need to increase my web thicknesses, or maybe I need to reduce the spacing of my stiffener. So generally, we do not do both the thing. So we provide one longitudinal one. That is fine.
But here in this case, only 12 mm is the web plate web thickness, but 20 mm stiffener thickness is there.
No. Web plate is 25 mm. I'm not saying here. 25.
Okay.
That's why stiffness is 20.
Sir, splices means what, sir? This splices, top splice, bottom splice.
Splice is just the name of connection, nothing else. Splices mean top plate will come, bottom plate will come, and this is the name of connection. Like the connection between two beams is known as splice connection. They just
What's
name
that?
it.
Connection between
two beams. And if you have this, that is known as just anchor bolt connection, like which will be bottom plate if any column, or if we have moment and column connection, this column beam and column joint. So this is known as MCF moment something. Different name is there, nothing else. Just the splice is known as this one. Then there is also
top flange, and which one is connected, sir? Top flange and top flange of this one, and
this is the top flange here, and this is the web connected, and this is the bottom plate connected.
No, bolt is connected between which and which?
No, throughout bolt. It is not like that. From the top, it can be bolted. From the bottom, these are bolt lines. You can see.
Okay. One more plate is there.
Yes, this is the connection. Okay, you can have a look. Clear. This is my web is going top plate, bottom plate, then bolt.
Above the top flange, there is one plate. Again, another
in this
bottom
connection,
plate.
it is very good. We also need to know how much plate we have if we are providing. If we increase one more plate or any other thing, so our planes increases, our capacity increases. So this connection thing is a different kind of thing. You can see web will be look like this: one plate here, and this in the middle.
Cover plate, inner cover plate and outer cover plate, something like that.
Yes. Cover plate or normally connection plate, splices plate. It is naming can be different according to the local naming changes.
For web also, one more plate they will be putting something else.
Same. Even you do not see any backing plate. Backing plate is also used, very common in connection, but does not required in this. These are the same web girder. Here we generally also use the deck. This is backing plate. What we do in the middle L by 2, we provide the flange, bottom flange maybe 50 mm, and as we go to the support, we provide flange as a 25 mm. Then at connection, we change our plates. So steel, that is why the steel is very different.
5% area बढ़ा के उसका दोनों साइड में.
That is different. But if you're changing the thickness of plate 50 to 25, that gives the lot of steel saving and also good for design. It's steel, that's why it's good. You can able to play anything if you able to understand the whole design.
Backing plate means what, sir?
Generally, what will happen?
Table 2 एक बार check करना पड़ेगा इनको फिर बाद.
What will happen if you have this in this connection? If your top flange and bottom flange are not matching, then we need to provide one extra plate to match our top and bottom flange. Like the right side flange is 40 mm and left side flange is 20 mm. Then I need to provide backing plate of here around 20 mm. To make the equal connection.
Packing plate.
Packing or backing both generally call it, because this also provide back up to your the remaining
Hmm.
space.
Okay.
So it depends. That's what I'm telling you. Steel is very good according to your observation.
For web, why cover plate is required? How they will connect it, sir? For web
Here,
connection.
here you can see, no? This is the web. One left and right plate, then bolting. Same.
Okay, this is
this is-
connecting that stiffener with this one, sir.
Not the stiffeners.
Web.
If you look, this is a longitudinal view. Okay. Now, if I cut the view and look it from this end,
Okay.
so it will look like this. No, stiffener will not come at this location at connection point. Stiffener, if you look, stiffeners are different location. This is my connection point. Stiffeners are here. At connection, you will not find any stiffeners. You see, they are very far away. Generally, we want to avoid this. We want to put our connection between two stiffeners.
What, sir?
We want
Between
to
two
put our
stiffeners.
yes, two stiffeners or 3/4 distance generally required. We do not want a stiffener new to our connection unless it is required.
This length of the plate, how much, sir? It is generally.
Generally, it will be calculated as per our design, like how much bolt is coming. Then we provide some clearer distance is there, like this minimum distance we need to follow it. From this to this is I think 2.5 or 1.5 is there. Then we need to follow this distance also 2.5 D, 1.5 D, then 1.5 D. So we can get the whole plate dimension. Minimum dimension I'm telling you. So if we are following minimum dimension, we can provide little bit extra, no issue. But
Sir?
first we need to minimum dimensions like 1.5 from the face of plate and 2.5 from this bolt to bolt distance. Or maybe 2.
No, not that one, sir. Single, now we are connecting some 4 to 6 plates for 36 meter, no?
Where we have seen?
Longitudinally.
Yes.
1, 2, 3, 4 plates. Then again some 3 plates. Total 36 meter we are getting, no?
Okay. Length. This one. This length is up to you. This is done by shop people.
No, how much minimum, maximum something that plate length?
Maximum is 12 meter, but generally do not come 12. Maximum always 11.5.
Okay, minimum
generally 3 meter. We do not go until very unless required 3 meter, 3 to 11.5 we play it.
But here this 2000 something and all one plate is there and joining that one with the
no,
other
it is
plate,
around 9 meters, 9.16. This
Okay,
not
okay.
2000 is your depth. This is depth. This 2000 is depth, but the length is 9 meters.
No, not that one, sir. This go above, sir. This 4
yes.
above it is there, no, 4927.5.
This one, this is for the stiffener distance.
Okay.
For stiffeners and bracing, all the distance. This is not for this plate. Okay. That's how
now,
we need to create also.
We have to put the stiffeners also, no, sir, now in our model.
I think not required, but we will be requiring when we do the design that I will mention. Right now, it is for single element. It is pretty much not able to put the stiffeners right now, but at the design, I think we can able to. But here are some options also available in steel. We can use the stiffener also. I have used those. If I go into the properties, I have used the stiffeners also. It depends upon the plate. If I am using combined steel girder, I was using steel. Here stiffeners is also come. But here comes like only steel if I'm modeling. If I'm modeling steel eye, then I can use the stiffener. If I'm modeling steel box, then I can use the stiffener. What the stiffener will do, you cannot able to see it, but in effective calculation, area and everything will be considered. But in composite, stiffener option is not here.
It is there here, no, sir?
Stiffener, I have not Let me see. I've not put it, but if we want it, we can able to just click on that. It will like you this left or right. It will ask you offline web. So I will create like web. It is asking where you want to put stiffness. So web. And now it is asking top to bottom. I need to create a stiffener also. Like this will be the flat. So if you look stiffener size, how much it is mentioned. Here it is mentioned little bit higher.
200 by
200.
20 by something, sir.
220 full length. So what generally it is required, like maybe I will mention stiffener. Flat H is asking 2 meter. Directly I will consider it. Uh, okay. Now how to reduce
स्पेसिंग देना पड़ेगा उसमें
this?
स्पेसिंग
Wait. Spacing will be around 6 meter. But I need to delete this. Why it is not deleting? Okay, it is not. Okay, I can able to reduce that. So, position from the top or bottom. Stiffener, 6. Then we have outside of depth. Why it is mentioning? Outside of
Spacing is in which direction spacing, sir? This is.
Now I am giving longitudinal direction spacing. But it is saying outside web.
Outside of deck. Just saying, sir.
Deck one. Okay. This is deck one, deck two. Maybe if I use this one. Outside of deck, what is it's 2 meter is higher for it. Let me change. Let me provide one. Shape nav not has been selected. Okay, spacing 6, stiffener, bottom TNA, and still saying. No, I have used this one generally. Never put it because for me, I can avoid it and then design this. I have used it. This is pretty much fine. But here, why it is doing like this? It will give me little bit extra sulfate also. Left and right. If I click right, yes, okay.
सर इतना करते हैं क्या
Yes.
सर को
हाँ करते हैं. We do that generally. If you design for detailed design directly from Meta, so you can be able to do that.
Sir, in STAD and all, these all things we will be creating or what, sir?
No, stat generally we do not do this kind of modeling, only normal modeling, and we increase the self-hit by 15%.
Okay, for
Hey,
the bracings
yeah.
and the stiffeners. Only we will
Yes.
model the 4 girders.
Yes. Only grillage.
Grillage, yeah. No connection, this, that,
Yes.
bracings and all,
No,
nothing will be there.
nothing.
Okay.
If I put this 2-meter stiffening. Located outside of there. What do you mean by this? Maybe the position when I'm selecting is not correct. Not required anything. This is fine. Everything is fine here. I cannot change anything. So I will try to use the bottom flange. Yes. Or this. Stiffener position data is correctly 6. Stiffener not has been incorrectly entered. But what I have to change here? Nothing is here to change. No selected estimate should be twice again.
सर
Yes.
ये आइडिया स्टैटिक सर
For steel connection, yes.
वो सर आप सिखाओगे क्या?
आइडिया स्टडी का मैंने यूज तो किया है, लेकिन यहाँ पे देखना पड़ेगा कितना टाइम होगा. स्टिफनर आउटसाइड ऑफ डेप्थ is mentioning bottom again. What is depth to? If I select आइडिया स्टडी का सीखना है.
हाँ सर.
Now it is showing, but okay. Got it. What is happening? Got it. This spacing is different spacing. This is this spacing. So right. So I can able to use. Now I need to provide left also. One right and one left. Zero, and another one if I put minus 0.5. Okay, got it. Now I can able to reduce this. Add. Now where had we gone? It is gone at this position. So here, this spacing will be 0.025. Now you can see here a little bit different, but why the direction is wrong, I do not Still no bottom right. Not that too. It will be from this location. And if I add this, this will be my around 4.45. 425.40. Yes, Stefan. Position data. I think I correctly enter it. Why it is still not taking? BR1 is already coming. Okay, just leave it. I can take it this, then we will get a discussion. Tomorrow I can. What did I? Yes, the bracing, you can see everything, but we need to connect those things by our top node also. So what needs to be done here? Let's select all. Even the top node is requiring it. Okay, that is fine. Here it will cause little bit confusion here. If you look, this is fine. This we can directly connect it, but these also needs to be connected. Why? Because everything should be connected. Okay, you're getting my point. What we need to do? Maybe if tomorrow I will do it. What needs to be there?
Why, sir?
Node.
Why we need to connect it, sir?
How the bracing will take the axial or the force, because we need to connect it with our girder itself. That's
Okay.
all. So
With rigid link, sir?
yes. So maybe I will show you one connection, like you will select this one. This, how it is going to be connected. So here boundary, rigid link. I will select right now rigid body, but we will change this, like we will define a connection. This is my master node. These two will be my slave node. And I want to copy this in negative y direction 3. So 2.5, 3 at the rate minus 2.5.
Minus y.
Minus y. So it will be connected like this. All I will do it in my free time tomorrow. So maybe tomorrow, not Friday, we will have class to finish all the modeling. Well, the steel modeling will take a lot of time if you are doing by self. If we are using any our this modules or wizard, that save a lot of time. We will do it later, but here you need to know about everything. That's why I'm doing like this. So we will have maybe Friday we will have class. So we will try to finish that. Okay. Bye.